Hello guys, so welcome back to our labs. In this lab, we're gonna, explore an application for the compare instruction or CMB. And this application is basically to find, the highest value between five values, or, the maximum number between five numbers. So basically, these are some grades for some students, for example, 69, 87, 96, 96, and 75. Okay, and we're gonna store, the highest value in a variable called the highest. Okay, so let's see how we can use the compare instruction to find the maximum value between these five values. First of all, we have here, first I'm gonna explain, the program overall, how it works. Then we're gonna, go to Visual Studio and see the lab report and how you can fill the lab report and run, the code itself. So, for instance, we have five, numbers. Then we should fill in, our x86. x86 basically is used all the time as, our, iterator. As we said, x86 as the register x86 is usually used as, iterator for our loops. Okay. So first, as we said, we're gonna, add 5 to x86 because basically we have five numbers in which we're gonna explore or know or determine where is the maximum. Then we're gonna point to the, the array, the grades array that has the five numbers, and we're gonna put this, address in EBX. Okay, to deal with, the array or the memory, we have to use either EBX or ESR, as we see many times before. Okay, we're gonna, put temporary, as we said, the highest value or the maximum value in AL. You can, of course, choose any other register, that's fine. Okay, so for this to happen, you should, reset or make AL 0. We're gonna explore why. So this step here, sub AL and AL, will make AL equal to 0. Okay, basically you have to do that because each time you're gonna take one value from the, or take one number from the array grades and compare it to AL. Okay, so if you didn't reset AL, if you didn't make it 0, it might have a value that is bigger than, 69. So 69 must be our guess, our first guess for the maximum number between the five numbers. So if AL, if you left AL with no resetting, it might have a value, a random variable, a random value in the memory, that which might be 69. I'm sorry, bigger than or greater than 69. And if 69 is really, the greatest number, you will not record it. Okay, as we will see now. And here is, the reason why you reset, AL. So here what we are saying is compare AL and the first, what is the memory location pointed to by EBX. So EBX now is pointing to the first location because of that line here. Move EBX offset grades. So, the bracket EBX basically is pointing to 69. So when you compare two numbers, basically you kind of, subtracting them from each other. Okay. So that will change basically, the carry flag and also the 0 flag. Okay, and what you want to do is that if AL is less than what's in EBX, the location pointed to by EBX, if it's less than, and this is the case right now because 0 is less than 69, you want to store the 69 in AL. So basically, this is the line in which we can store the value 69 in AL, but we want to execute that line or instruction, move AL EBX, only if AL is less than, you know, the number pointed to by EBX. That's why here we say jump above. So jump above here means jump above basically means if A is above or greater AL greater than what's in EBX, then jump. Okay. So if AL is above or greater than what's pointed to by ABX, then jump. So in that case here, I'm sorry, AL equal to 0 is less than EBA, what's pointed to by ABX, which is 69. That's why we will not jump, and we will go and execute that line. And the AL will change to 69. So 69 is our first guess for the maximum values. Okay. Let's assume that you didn't do that line, the subtract AL and AL, and you know the default value that was in the memory, for example, was 100. Okay. And if you didn't reset, then you will not take the 69 or the 87 or the 96 or the 96 or the 75. So you will not find the maximum value because the random value that was in AL before execution was greater than all the values in the array. So you don't want to, you know, let yourself into that trap. So that's why we should reset AL before going into the loop, basically. Good. So now AL has 69. This is our first guess for the maximum number. Then we should loop. For making the loop, we should increment EBX and, you know, loop again. Loop is, you know, loop is an instruction in x86 assembly, which do two stuff basically. First, it decrement ECX, the register ECX, and jump if the decremented value or ECX after decrement is equal to 0. So in that case here, ECX is equal to 5. So after the loop, it's equal to 4, and the 4 doesn't equal to 0. So it's gonna, I'm sorry, if it doesn't equal to 0. So it will jump if ECX doesn't equal to 0. So 4 doesn't equal to 0, so it will jump to, again, this line here. So since we incremented EBX, now EBX is pointing to 87. 87 again is greater than AL. So jump above will not jump above next, will not be executed. And or we will not jump, I'm sorry, we will not jump. Okay. And we're gonna execute the line move AL and EBX again, and AL will have now 87. Then we increment EBX, so EBX will be pointing to the 96, the third element in the array, and then we loop again. When we loop, we decrement ECX, it becomes 3, but 3 doesn't equal to 0, so we're gonna jump to again. When we go to again, now we're gonna compare AL, which is 87, with 96. Again, AL is less than, not above, it's less, you know, than EBX, so we will not jump. Jump above next will not jump. And we're gonna again move AL and EBX, so AL will be 96. Then we increment EBX, so EBX now is pointing to the second 96 or the fourth element, which is also 96, like the third element. Then we loop again, so we decrement ECX, so ECX become 2, is still not equal to 0, so we're gonna jump to again. And again, we compare AL and EBX. AL is 96, EBX is pointing to again 96. So again, it's not above, it's equal, but it's not above. Okay. So, and one point here to, you know, to make your life easier when you make the compare, and if you wanna know if the jump will happen or not, jump above, you can translate it in another way. So you can say that jump will happen if the carry flag and if the carry flag equal to 0 and the 0 flag also equal to 0 at the same time. At the same time. But it's easier to explain it, as with with the translation jump above, saying that if AL is above, we're gonna jump. If it's not above, it's equal or below, then we're gonna we will not jump. But in the when we go to the lab and see the lab code and and execute the program, we're gonna look at the carry flag and the carry flag and the 0 flag, and we're gonna see that's really if AL is greater than or above what's pointed to by ABX. At that case, CF will be 0 and 0 flag will be 0, and we will jump at that case. So now going back to the compare, now the compare is comparing 96, which is AL, to also 96. So that's equal. That's not above still. That's equal or below. In that case, it's equal. So again, we will not jump, and we're gonna move again, 96 to AL. Then we increment EBX. So EBX now is pointing to the 75. And we loop, so CX will become 1. Again, it doesn't equal to 0, so we're gonna jump to again. So in the again, we now compare AL, which is 96, to what's pointed to by EBX, which is 75, and that's above. So that's the only case in which we're gonna execute the jump. So we're gonna jump to next, because if you didn't jump, then you're gonna store 75 in AL, and 75 is basically not the maximum value. The maximum value is really 96. So in that case, we're gonna increment EBX. Now EBX will point to some location in the memory beyond the 75 location, and the location that has 75. And of course, as we will see now, we're gonna exit the loop. Okay. Now loop again will decrement ECX. Now CX equal to 0. Since ECX is equal to 0, we will not jump. So we're gonna go to that line, move highest and AL. AL now is 96, so highest will take 96 as well. Okay, guys. Now let's go to the and execute that program in Visual Studio. So this is basically the other screen. As we will see here, is the code, and here is your report. Okay. So in the report again, we have our normal traditional table in which we put the values each time we do we execute a line in our code. Okay. So let's execute. So run to cursor. I have here from before all the registers and the variables that we wanna record, and here is the flags. We're gonna in particular look at the carry flag and the 0 flag. Okay, after the compare execution. Okay. So, and as you see, guys, look, AL here had 36. Okay. It's no problem in that case because 36 is less than all of these. But if it has, for example, 100, this will be a problem. And again, that's why we do the sub AL and AL. Okay, so let's use the first command. So ECX become 5. So you should write here 5. Then we go forward and we moved the address of the grades array into ABX. This is the address in the array. Okay. Now we move forward to the loop now. Now I want you to look at how the 0 flag and the carry flag will change after the compare, and look and always look at the jump array and the carry flag and the zero flag when we, to determine if we're gonna jump or not. We're gonna jump only if the carry flag is equal to 0 and the zero flag is equal to 0 at the same time. That means it's AL is above ABX. So we expecting after that, line, since ABX is 69 and this AL is 0 now, to move what's in ABX or what's pointed to by ABX to AL, which is 69. So let's do this. Look, guys, the carry flag is 1, zero flag is 0. So when we do the test for the jump or not jump above, since we want both the carry flag and the zero flag to be 0 at the same time, that's not the case now because the carry flag is 1, then we will not jump. And we're gonna continue to move AL and ABX, that line. And in that case, AL will change to 69. Look, guys, here, it's 69. Good. Now we're gonna increment ABX. So it's incremented to 40, it was 44 here, the last two digits to become 45. Now the loop, this is our new, instruction here. We said that loop will do two stuff at the same time. Will decrement ACX by 1 and the jump if it's not 0. I'm sorry, if it is not 0. Okay. So let's. I know it's confusing a little bit. So let's of course, because we change the program, it will complain a little bit. So let's let's edit. That's fine. We want this edit. So ACX, look, guys, after executing this, it will become 4. Edit. Oh, let's ignore it. That's fine. Yeah, it become 4. Sorry, guys, it doesn't, accept, the inversion or the edition, the editing that we did. So we're gonna keep it. I'm gonna change it in, in the report. So if this will, this comment here, you can ignore. It will jump if it doesn't reach 0. Okay, and ACX now is 4. It doesn't reach 0, so we're gonna jump to again the label. Okay. Now ABX is pointing to the 87. Okay, so this is not above AL, or AL is not above ABX. So again here, the condition is not satisfied. So zero flag is 0, carry flag is 1. So we will not jump, and we're gonna move what's in ABX, what's pointed to by ABX, which is 87 to AL. So look, guys, AL become 87. Then we're gonna increment ABX, so the last two digits become 46, and we will execute the loop instruction. ACX will change to 3, as you see, guys, here 3, and we go since it's not 0, and again ignore the comment here. The comment is wrong. It will jump if it's not 0, so we jump. Now ABX is pointing to the 96. So AL is not above 96, so we shouldn't jump here, and we should execute that line, and the AL should be 96. Let's check that. Yes. Okay. Then we increment ABX, it will become 47. We're gonna make the loop. This will decrease ACX to 2. This is what's happening here. 96 again, AL, which is 96, is not greater than or above 96. So again, we will not jump. We will not jump. And we're gonna move against the 96, which is okay. And we increment ABX, it will become 48. And we're gonna loop here, so ACX will become 1. It's not 0, so we're gonna jump to compare AL. Now, this is the only, the only iteration in which we execute that, that instruction jump above, because really 96 is above 75, which is the location pointed to by ABX now. So let's check that. Good. And now look at the carry flag and the zero flag. Both are zeros. And that's the condition to make the jump for jump above. So we're not we expecting now, once we execute that line, we go directly to that line and we skip that line here. It's a check that, yes. It goes to next and it doesn't go to and executes that line. It goes to next directly. Now Apex will change to 49. Of course, that's outside that range, but this doesn't matter because now when we execute the loop, ECX will become 0, and since we become 0, we will not jump. Look, guys, we will not jump, and this ECX becomes 0. And now highest will take the 96. Okay, guys, that was basically it for this lab. One note here: when you do the jump above next here, you should write it down 1 or 0. 1 means 1, jump means 1, and 0 means not jump. So we have here 5 loops, so you should write 5 values like 1 0 1 1, whatever, and for loop here, since loop affects ECX, not just ECX, so you should write the value of ECX after executing this instruction. That's it, guys, for this lab. Thank you very much for watching, and see you in the next lab. Bye-bye.